This video gives a short impression of Chapter 2 from the Handbook for Teachers about Game-Based Learning in Mathematics. This handbook was developed within the European Erasmus Plus project, GUMA. This chapter is about the state-of-the-art on learning and teaching mathematics with digital game-based learning. Here you will find information on the main objects for the research on DGBL mathematics education. There are a lot of questions open that researchers are still investigating. So, in brief, you can be informed on what is the world of academic research says about digital game-based learning in mathematics education. Reading this chapter, you might be enlightened on questions like: which is the real pedagogical potential of digital games? How could digital games transform mathematics education? According to academics, digital games provide a rich learning environment for digital learners. This could give potential to mathematics learning to overcome possible lack of motivation and enjoyment among children. There are numerous studies pointing out the benefits and the potential of existing digital games. Also, a lot of research results report the effectiveness of DGBL on improving students' motivation and positive attitudes. Digital games alone cannot necessarily bring change to educational settings. There is a need for designing transformative games. Games that would be able to transform learning rather than facilitating it. This could support the change of traditional practices towards more meaningful pedagogical approaches. Approaches that fully exploit digital games' affordances. It is worth noting that most of the reviewed studies predominantly use drill and practice games, which is a kind of gamified version of traditional paper-based exercises where procedural skills are required. In this way, DGBL seems to provide a chocolate-covered broccoli for mathematics to be less repulsive. The question that Kafai poses is about the need to sweeten the learning of difficult ideas through games. Do we need instructional games to make difficult ideas easy and fun to learn? What messages about learning are we sending to students playing these games? Through programming and constructing digital artifacts or game principles, students become designers and their designs become the object of their learning. In this way, learning of mathematical concepts can be published and, thus, studied and analyzed to provide evident answers for the learning potential of DGBL. Finally, a highlight mainly for those interested in research in this field. Some scholars point out that even though the main interest of the studies in this domain is the effect of DGBL on learning mathematics, these studies have been predominantly conducted by researchers of educational technology, outside the field of mathematics education. So, there is scope for researchers in mathematics education, as well, to pose new questions and search for the answers. This video gives a short impression of Chapter 2, from the Handbook for Teachers about Game-Based Learning in Mathematics. This handbook was developed within the European Erasmus Plus project, GUMA.